Holen, Laxia, Mittel. Good. The first thing I need is well, a part of the algorithm. I'll be right back. Let me turn on the light and close the curtains. Yeah, so a part of the algorithm is merging two singly linked lists. But in the end, I only want to use this for utils list. So let's just use that list. And then in order, that is a double linked list, but well, just, you know, we'll only forward it, right? Pretend that it is a single linked list. However, I need to sort a list, and we don't have sort yet. So I'm just going to fill it from a sorted vector. Let's just cut this vector in two. First, there's a random vector. Okay, now we want to print it. Let's do this as part of a stream. I'm just going to say v1 equals and then print v1. Oh, I have support for that already. I don't have to write that. But where? I guess. What the fuck is the noise from outside? I think that. I have to put on my headphones again. I had them off. I pity you guys that you have to listen to this nonsense. I mean, sometimes you read in the news that someone, you know, does something completely crazy, and then you think, oh, that must be a lunatic. But if someone with a motor like that is racing through my street, I might just pick up a gun and yeah. Okay, I put my headphones on. Ugh, silence. Okay, so yeah, this should work, I think, if I include that. Let's just try it out. Oh wait, splice is a list thing. Yeah, I probably meant to do this utils. Maybe I can use splice to do this directly. I'm not even sure actually. Let's list one. Tools list. Ach. Why is that not working? No matching function for call 2. Splice, yeah. Space iterator. Standard vector. Why not? Let's correct it. Oh, extract range. Oh. Oh. Shit. Yeah, that makes sense. Okay, this is nonsense. No. Okay then. Let's make these vectors again. Mm-hmm. Trailing characters. Oh. So now we have two vectors with random numbers. I could, well, I don't know why I did this, but well, I could have just created two vectors and then filled them separately like this. But this is, in the end, is our real input. You know, I just want to sort input. But now we need two lists, so we start over at this point, and then therefore I split them up, and then I want to copy this to list, to my list. So utils util list int L1. Now surely I can just copy all the stuff from a vector. Hopefully. v1 begin, comma v2 end, and v1 end. Don't tell me this does not compile. Scary, but it compiled. And it transferred to my list, and it is really random. Okay. Okay, we have two lists. Now, how do you merge them into a single list? In fact, a low level, so I want to use the node the node type from my list instead of iterators. List. Node type. It's even public. Not that we can access the node. So I have a node type, and how do I get the first? If I have the first node, then we're done. We're done. Or from there, we can access all the nodes. Now, or value types actually also correct. Good enough. Yeah. Yeah. Let's just get the value type. So I did just the first element. That would be the dereference of begin, right? Yeah, nobody knows where that is defined. Oh, there, up there. That gives me an iterator. Oh yeah, I can just call front, obviously. Front gives a reference, and the reference is the value type. Const reference. Well, it depends, but it depends on if you have a const iterator or an iterator. Must be another one here. Reference, value type reference. Okay, so the list type. Pointer. No. Yeah. No. Well, why not? Let me quickly show what I said on Discord here. At some point you have, let's say, well, okay, so you have this list. It's a double linked list, but ignore all the previous pointers. So I do pretend that it is just B is the base, and that points to 6, which points to 5, and so on. And then 4 is the last one, and it points back to the base. So it's circular. Then the merge sort is first sorting the first two elements. So 5 is the smallest one, so we get B is pointing to the smallest one, and then the smallest one is pointing to 6. Already was doing that. And then the next step is compare the 3 and the 1, and so on and so on. So there is a merge in the sense that, say, here we have a list 5, 6, which is sorted, and 1, 3, which is sorted. And the merge then exists of picking up the smallest element. So 1 is smaller than 5, so we begin with 1. And then 3 is smaller than 5, so we put 3. And then this list has reached the end, so then we link 5 and whatever comes next. So then we're done. And then later I said, okay, so at some point you have this situation where you already have lists that are sorted down. And there might also here be lists sorted down, but the example was so short that 8 does not have anything below it. But imagine that this is a long list, and this is a long list, and this is a shorter list and a shorter list. Then in this situation, we're going to merge the list of 8 and down and 7 of down into a single list. And then the one is going to point to that single list. And then whatever the smallest one is, so it's going to be 7, is pointing to 2 again. So this becomes then 1 points to 7 points to 2, and 7 points down to 8. Yeah. So on Discord, I call this P. And therefore we call this P, because P is pointing to the first, well, no, actually it isn't. It isn't. 8 and 7 are my two lists. P is pointing to the list that whose next pointer points to the first list that we must link, merge. Yeah. Anyway, now everyone knows what the algorithm is. And I'm not going to call the pointer, I'm going to, P, I'm going to call it, I really want to use L1 now, but I already used L1. But hey, it's the L1 pointer. You know what? I'm gonna call L1 L1 list 1. And L2 list 2. Now we can call this L1. And that is then a value type pointer, which is more than an int. It's a value type. That includes the node. Okay, how do we get the node? No, how do we get the pointer to, well, it's v1 begin, of course, but that's an iterator. So we must convert this iterator into, oh no, well, I already figured it out. It was just front. But that returns a reference. So we want to have a pointer to, look at that. Ta-da! Okay, and then L2 is pointer to v2 front. We don't. So theoretically, it should be possible, you would say, to get a node pointer from this, but it isn't, because node is a protected base class of the value type. So we do have we need a value type because we need to compare the integers, of course. So we go to the pointer again and then the list thing. That is a value type, and the value type is a class. This class, which is derived, protected from node, and has the private t. T is an int. So having this class, I can read the data by casting it to an int. Can't, however, access my node. But we know that the node is the only base class, so this pointer of node equals this pointer of value type. So I'm just going to cheat and reinterpret cast it. If you would use a static cast, it's going to say blah, 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 blah. It's protected. But if you do a reinterpret cast, then it doesn't know. It doesn't know that it is protected. It doesn't care, actually. Because I want to work with this node here. I still need the type, but we have the type as a node type in the list. So we go all the way back. And then I think at least that I want to work with the node pointer. Maybe I should work with the value pointer. I can work with the value pointers. You know, the reason I don't want to do that is because if then I want to follow, I want to read the next pointer, then we get an iterator, and the iterator is well, it just derives from a const iterator, so as a node pointer. So then we don't have the pointer itself. We have, actually, do we not have that? So if I have the iterator, then we just have the node pointer. Why would I work with node pointers? No, I can just work with. Oh, it is not. Never mind. I thought. Well, you know, it is double indirection. If you want to get the next pointer, you mean you have to dereference this thing, and then you get the next to get. This is a pointer to the next pointer, which is a pointer to the next node. So you have to do 2 pointer dereferences to get the next node. But if I work with node pointers directly, then there's no difference, because then the iterator is a wrapped node pointer. Yes, okay, so we might as well work with iterators. I'm gonna do that then. Yeah, let's just work with iterators from the start. I mean. Still, it feels different. Why does it feel different? So my pointer was a pointer, and it pointed to the value type. Yeah, which is the value of that pointer then was equal to this pointer of the node. While the iterator is a wrapper around the node pointer. So this thing has the memory layout of my iterator is exactly the same. It really does not matter. It's a good thing. Yeah. But then we have to use begin. And obviously not that. Delete till the end of the line. No, delete to the end of the line and then append. But then before I press escape. Okay, so what we need to do here is there is a problem, damn it. I want to change the previous and next pointers. And we don't have access to that from the iterator. The iterator is actually I do, but only if I have access to the PTR in the iterator. I don't think I do. Yeah, I need. My God. Shooters list. I need to change this pointer and that one. Now it's a struct, so I can change them, but then I need a non-const pointer to the node. And the thing that we have is a const iterator. Which has the node pointer. But that means that we can only do what we want if we can get the value of the pointer. And we can only get that, well, we can get it, but only after it is being cast to a value type pointer. So we would have to cast it back, which is not allowed because the node pointer is protected. But we can hack access by do a... Yeah, that would be the only way. So it is hack access by reinterpret casting whatever this returns back to the node pointer. That would still work. Okay, so let's just use the star. That's always easier. So I want to do node type pointer. We need a non-const node type pointer. Node. And you can only get that by doing a reinterpret cast from the pointer to the non-const reference, which is the dereferenced of an iterator, not a const iterator. So this should give me the node pointer. And because that is so ugly, let's make it a function. And this is long, so let's make it auto or just node type. Hell, I'm gonna call it node. Even type is too long. What? Like that. And this should compile. Or not. Vector iterator to list iterator. That's not gonna work. V1 begin. What a bullshit. List 1. List 2. Yep, so that compiles. Okay, I could print, can I print this list? Yeah, already did that, yeah. So we can merge, let's say we merge 2 into 1, and then we print 1 again. It's no preference. Now I have a merge, but that merge is for a double linked list, so it's twice as slow, say, than treating this as a single linked list. So I'm going to re-implement that merge in this file. Let's put that even up here. It's just a test anyway. Bum, bum, bum. I'm feeling like making a few abbreviations. I mean, after all, I did use list type before. I don't know why I wouldn't do that. Okay, much better. And I need to remember that, but not use it here. What we're going to do is merge. Well, it's, I could say, yeah, it has to be a free function because I can't, that it just is not. Maybe I'm going to make. Well, actually, yeah, I'm going to need it. So for the sort. Yeah, but if I do that, it would be a private function. Let's begin with the free function in this file while I'm developing it. So I'm just calling it merge then, and then free function means it's not a member function, so we just have to pass both lists. But this is then merging L2 into L1. And then after that, we print it again. Now list is a list, right? This is slightly problematic. I also have to update. No, you can't do that, right? I mean, this is just a merge. So, I mean, it's an iterator and we merge stuff, but I think I have to return an iterator as well. Like the first one then. Yeah, probably. So let's just put the result in L1. And then I only have the first iterator. So we have to print the thing. Let me just create a new one. Oh, this type. From L1, and then what is the end? You don't know that, do you? It's going to be the end of one of them, but we don't know which one that is. Oh, I should know that. Oh, wait a minute. Let's use null pointers. So that means that we need something that prints a pseudo single linked list, which just ends with next equals null. If you understand what I mean. So I'm going to use utils print using, and then we print L1 using I don't know, single linked. empty list. I don't think we'll ever get an empty list, but if it would be an empty list, that would be a node, a null pointer. So we just convert this to a node. And then we do a while node. See, now I need a value. So I have to cast it back. That is too annoying. Yeah, I need to assign it and test it. So it probably has to exist already. No, it doesn't actually. I think you can just put the whole thing in here. Declare it. Declare it and test it. They seldom do that, so I'm not even sure. See if that compiles. Didn't declare merge yet, apparently, but okay, we did get past this point, so that works. So we can just set up the reference iterator to get the value on this point. But that means that my single linked lists must end on null. And this would be my single linked list, of which we only have the iterator. Which means I have to corrupt my list. Because instead of pointing to the base, the next pointer of the last element must be pointing to null now. Now this is scary because after doing this, we cannot destruct list 1 and list 2 anymore. Because then we crash. So maybe you also need a recovery. So instead of null terminate, I'm going to do assign or something, or change next. I can't type. Change next. Change next of that iterator with a null pointer. Yeah, let's write that, or not yet actually. Now before we leave, then we fix it again by calling change next again, but now with the stored pointer. So n1, and I guess that the end does not invalidate that, but the previous also not. I mean, we're just not touching list, right? Well, we actually going to do a lot with list. Completely fucked list up. I just don't want to crash. Maybe I should just clear the list. That doesn't work either. Okay, well, let's just crash. I mean, I don't know. Or we call exit underscore. Then it exits the program without destructing. What we do need to do this, and I'm going to write it like that anyway. Okay, so we change the iterator into a node. And then we set the node next to next. And we return the previous value of next. Right, okay, now I have null terminated list anyway. So we just forget about the merge, we can test what happens. This should print the same as this one, because it prints to the begin. We didn't change anything yet. Could not convert from value type to iterator. Oh, no. Yeah, print using sees that this is dereferenceable. This is an iterator, right? And if you try to print an iterator, then it's actually passing the dereference value. So I think print using is in the wrong here. Oh, that's funny. Yeah, it does. It dereferences it. Is pointer like dereferenceable? Yeah. What you really want to do is call this one. No, it's not a member function pointer, so I need... Yeah, I just need this to be false, but it is not because it is an iterator. Oh my god, this is not very well documented. I must say I have a problem rereading it. I guess you could pass a lambda and then we get this one, which is then producing 2 by standard function. Let's see how is that printed. That is again producing 2, but then the standard function. And I suppose that the standard function is not dereferenceable. So then what? I think that should work. Might work. And now we try to use common sense, because in the end print using should just be common sense, but this doesn't work, so instead I'm going to pass a lambda. Which is probably past the O-stream reference. I mean, I'm not even sure actually. I would say both are past. Thank God, no, I don't know anymore. Let's have a look at the dereferenced type. Oh fuck. So that also won't work. It's going to call it with the dereferenced iterator anyway then. No, it seems you can't use print using. I'm shocked, because the whole idea of print using was that you can print everything with it. In that case, we have to do something ugly, like can either pass. Yeah, that's not easy. That's why I wrote print using, to be able to use it inside this thing. I think the only option is to implement the printing right here, or do the printing from a function that we call. That is probably the best thing. So let's say dump list. Dump list by iterator. To implement that. That's my previous print. That was a single linked list. Yeah, we have to be in a neighborhood because we need code from that. What is this one? Okay, so then I do continued, because you want everything on one line. Continued control flag. And dump list that prefix. And then print that as well. And we finish with printing this. Continued. Oops. Yeah, I don't know. The list cannot be empty now or what? If yeah, okay. If it is and then yeah, then it doesn't work. So okay, but will never happen. Oh yeah, like that. Segmentation false. Oh, what? Base node next is null. When does that happen? Extract font. Clear. Oh, this is our crush. I'm sorry. So okay, so it worked. It just prints the same list, and then we crash, like I said, because I corrupted the whole list. I think I'm gonna work around that. Some for this. Nope. Underscore exit. It is ugly, but we are going to do this. No crash. Did it not say that it does not close file descriptors? I mean, that would be a bit much. Any open file descriptors belong to are closed. Oh, okay. Don't want to be leaking file descriptors. Now let's implement the merge, finally. Merge takes 2 iterators and returns 1. Yeah, I think we're going to have, we need 2 iterators, one for each list. And we want to advance one of them or the other, depending on which one is smaller. Why am I feeling confused? I think I have to work with a reference to iterators, or even pointers to iterators. Nah, the thing is a pointer itself. Damn it. An array of iterators. Yeah. Let's make an array of iterators. An array is, by the way, it doesn't even have a constructor. So if you do this, then you have uninitialized memory. There's no default constructor. And then we want to assign them, of course. I'm just going to assign L1 and L2. But to L1, oops, the index of L1. L1 index, and then this to 1 minus L1 index, or to the other one. I said minus. Why does it appear? No. So int L1 index is, and I want 0 to be the one, so iter's 0 must contain the smallest one. So if L1 is less than L2, and the index of 1 must be 0. So now iter's 0 equals to the smallest one, and iter's 1 equals the larger one. Which is actually going to be the smallest. And yes, this is nonsense. Now what? If L1 is the smallest, points to the smallest, then we have to leave it like that. So say L1 points to a smaller thing than L2. That means that this is true, that means that this is 0. That means that L1 is assigned to either 0, and that means that the smallest is assigned to L1, which we're going to return. But now I want to advance L1, not L2, obviously. So, and if that is the other way around, L2 is smaller, then I want to advance L2. So we want to advance the iterator that is in index 0. Is that correct? Okay, now we did put the smaller one in 0. But after advancing it might be different. So actually I want an integer smaller. Smallest also, I don't know, let's call this smallest iter. I need an integer that is called smallest, and it starts at 0. That is true. Although on the other hand, you might as well use 0 here and 1 here, and then set smallest to the smallest, as in L1 is in 0, so smallest is either 0 or 1. Not going to change that anymore. Okay, so now we advanced the smallest iterator. For now I'm going to ignore that I can reach the end. That's difficult enough without that. So my lists are infinitely long. And we also have to merge the list actually, but right now I just want to continuously advance the smallest one. So this is going to be an infinite loop then. And smallest must be re-evaluated. So after doing this, smallest might change. we compare the reference values of the two iterators, and then the smallest one is again 0, 0 or 1. But we can't. I mean, and now I need a loop, and now you're thinking this loop has to terminate as soon as, of course, the last advanced iterator reaches end, and we can't do this dereference if it reached end. So rather, I would do this like that, and then have the loop here. And then test if we reached end. And reaching end means that we get the node from the iterator. And read next. And then if that is null pointer, then we exit. So as long as it, well, it's, or I'll write it out. The last element has, well, actually, I should set the base to this. Now below in main we set the next pointer of the last element to null pointer. Which means that we should not exit yet. I mean, this is dereferenceable, but just the next pointer isn't. So instead of setting the next pointer of the last element to null, I should just set the end to null, I think. Which means that we should remove the standard previous here. Which is yeah, why not? So now if the next pointer is a null, oh wait a minute, if I do that, then begin doesn't work anymore. But that's not a problem, because we already called begin. So we first call begin and then we set begin to null. So let's add a comment. Okay, so as soon as we find that our iterator, the smallest iterator, or the one that is just advanced, it's now maybe not smallest anymore, but as soon as that becomes end, then the node will have a next pointer that equals null. So then we leave this loop. Otherwise, smallest is reinitialized, and we increment the smallest again. I'm just said that this is now being done here for the correct values. And the only reason I have to do this double here before the loop is because we need this. Yeah. We just need a copy of the smallest iterator at the entry, so must compare them. Or we don't need to do that, and we just put smallest iterator. Well, we still have to make the compare then, but it's kind of silly to. I think I do need, and I think that in the here the smallest would not be defined anymore if I put an int front here. That this is really the end of the scope. So we have to put it here, which is kind of stupid. But okay, and then of course we need this initialization. I don't think we need this. Just don't need this. And then this can be done simply by, well, checking it, which is smaller. And I'm very unfortunately, we still do this same check again here. I don't want to do that check twice. It's unacceptable. No. I just have to change the loop, I think. So we go all the way back. Till the way it was. Oh, what is this? Yeah, I want to do it like this. But that means that we need to make this a typical infinite loop. That we just break out after this. No. Like this. I was almost putting this here and then that as the last statement, but then this would be tested as well before the first entry, which is not needed. Is it? Well, actually it is. I mean, that would be the case where yeah, well then I'm assuming that neither is end, because we already dereferencing them there. So no need to start with that test, we just test after incrementing. Okay, so the smallest is incremented, and then if as soon as that is reaching the end of one of the lists, we stop. Which means that here the rest of the rest of the remaining list must be appended to whatever we return here. So that would be no, that doesn't work. It needs access to smallest, I think, also here down there. So we just initialize it. So if let's see, so the smallest one is that is this one, has reached the end, and if the other one, now if the one that we return is the one that reached the end, then we have to append stuff, right? So I think if smallest is unequal the initial smallest, then we have to do something. I'm not sure though. Let me think about this. So the smallest, so this is the break, and then we get here, which means that smallest is empty. So this list is empty. It's the other way around. So if the initial smallest is empty, I don't know, it feels more logical like this. Well, not empty, but unbelievable. We reach the end of the one that we're going to return, then there is still stuff left in the other list that must be appended to. So might as well do this. Now to think hard, that means that we need to have the access to the node of this one, and well, the last one. And the last one, I think, is still pointed to. No. Sorry, this iterator. Next is null, so this is end. So we need the value of this iterator before we incremented it. And it was just incremented. I have a bad feeling about this. I'm going to screw up the previous pointer so he can't go back. He can only go forward. So lost is so I need access to some node, and the node is going to be the last node. Get node last. And then last node next. Must be the node of the remaining list. So that is get node. Iter 1 minus smallest. Which then means that the next pointer was pointing to the base of the list, and now it's no longer pointing to the base of the list, but it's pointing to the first element that was remaining in the last list. I think this is correct. Okay, if we run this, then what will happen? We just advance smallest. I'm still not merging anything. We just advance the iterators. And then this is the only thing that actually is doing something. So I guess it kind of depends on what the first element. Yeah, it's not enough to test it. Let's continue here. So if we do not reach the end, sorry, the smallest, oh boy. I still have to do the merging, and that depends on, no, smallest is the initial smallest, okay. That's good, yeah, so the first element is already in place. And as long as the smallest doesn't change, then we just iterate over that initial smallest. So nothing has to be done. And then at some point, smallest changes value. Then we need to do something. Yep. If the next smallest is different, so if it changes value, then you have to do something very, very much like this. Very much, maybe even exactly that. I want that the next pointer of the list that we just left is changed to point to the other one. The one that is smallest now. That is last, right? So yeah, this line is the same. And then of course this line is the same. I just don't know which value, what to use here. 1 minus smallest or what? Yeah, the other list, I guess. Okay, so this points to the smallest one. So last points to the smallest one. Then we increment it. And now the other one is the smallest. Then the other one must be its 1 minus smallest, because it didn't change smallest yet. So then the previous smallest is just switched from pointing to its own node to the now smallest node of the other list. And smallest is changed to next smallest. And next smallest is different from smallest. So this is simple. This is equal to next smallest because it is different. Or we just put this up front and then it is equal to smallest. Poo-poo. Nope. does not work. We're not incrementing something. You get an infinite loop in merge, obviously. Well, I find that strange. I see increment, increment, increment. So why are we not crashing or something? Let's just start at the beginning of this function and see what happens. We're gonna break at I don't know, 36. Is this program printing the list? Yep, it's printing the list. Very good. So list 1 is 89. L1 should be 89. Can I do that? Probably not, because it's GDB. Oh, actually, we can do it. Yes, and L2 is then 79. Yes. Therefore, L1 is not smaller than 1. The smallest one is, why is it? Here it's called 0 and 1, and here it's called 1 and 2. It's way too confusing. And I fucked up. I changed that to into a 1. Okay, so again, L1 is 16 and L2 is 52. This time L1 is smaller than 52, so we get smallest must be 0. And smallest iterator is obviously pointing to the smallest value, which was 16. And then last should be pointing to 16 as well. And it's pointing to 72. What? My post increment doesn't work. Line 43. Arg. Forty-three. So print iter smallest is 4. After this line, last should be equal to iter's smallest, aka last must point to 4, because this is post increment. Step, finish, Wait a minute. This is returning another reference, isn't it? Yeah, it's returning a reference, so the plus plus should work. Oh my god. Okay. How on earth did this get through the test suite? I'm so disappointed. Well, that's not an improvement. Hey, but it's finished. No, it's actually not that bad. We have the smallest one at the first place, and it exactly added 10 things. Just the wrong ones. Okay, guys, I would love to continue, really love to continue, but I'm going to bed because I wanted to go to bed half an hour ago, and again, it's getting later and later and later. So, sorry, but if you want to see the continuation of this, you probably don't. Good night.